All right. Good evening to all the grade 12 students. How are you all doing, students? All right. Welcome back to the next series of your WOC. We are back with one more most important video, that is day 8. Yes. So last 30 days for your board preparation, students. As mentioned, I will be doing, let us go back a bit. I'll be doing your 30-day strategy, which will be covering all the 10 chapters. So in this particular series, I'll be doing, as mentioned, multiple choice questions, very short answers, and that is 1 mark question. Short answers where I'll be including 2 mark question, 3 marks questions. Along with this, in this also, I'll be including a long answer question type where I'll be including the 5 marks part. All right, it's a part of that particular. Then assertion reasoning, content-based, analogy type, and important board questions. So now I have started with a chapter that is nothing but HaloAlkanes and HaloArenes. Alright, students. So I have completed already one chapter with all these parameters. That is nothing but solutions. So solutions is already done. Please watch the series. Now I'm doing HaloAlkanes and HaloArenes. Let's dive into the video without wasting time. So today we are going to do the most important topic. That's nothing but assertion reasoning questions. Very important, students. Here maximum students get blank. They say how to assert, how to do the assertion, how to do the reasoning. Don't worry, today I'm going to teach you 19 most important questions. Very important questions. If I have to put star to the infinity, 19 most important assertion and reasoning questions of haloalkanes and haloarenes. If you study these na, all the complete chapter will be covered. Let's start. Concentrate and listen carefully. You can apply your headphones or earphones, earplugs, pods, whatever it is, to concentrate and understand. Let's start that. First question is assertion. Read carefully. N-pentyl chloride has higher boiling point than isopentyl chloride. Reason: the branching of the chain makes the molecule more compact and therefore decreases the surface area. So I have to select the appropriate answer. So don't worry, you've understood the question. Now let us assert, let us first understand the question. What did they say? N-pentyl chloride has higher boiling point than N-isopentyl chloride. Let's see whether it is correct. So first I'm going to take the assertion part. What did they say? N-pentyl chloride. Okay. N-pentyl chloride. We will assert here, assertion we will do here, and then go back and tick it. 1, 2, 3, 4, 5, and chlorine. So this is your CH3, CH2, 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 and CH2. Perfect. Now what they said? Isopentyl chloride. So let us write isopentyl chloride. Correct na? Chloride. Now how is isopentyl chloride? One carbon where there's an iso group here. One is hydrogen, one is your CH3, and one is your CH2, CH2Cl. This is isopentyl. Point number 1. First understand what did they say? They said N-pentyl chloride has higher boiling point than isopentyl. First of all, boiling point depends upon what factors? You only tell me, students. Boiling point depends upon concept number 1, surface area. If the surface area is more, boiling point is more. Simple logic. Only one logic will apply. I'll not talk about branching. That comes next. Okay. Next comes. Same concept. If the branching is more, your boiling point decreases. These two concepts, can you remember? Yes. That means indirectly, if I have to tell you, simple logic, I have to tell you next question. Okay. I have to tell you boiling point is directly related to surface area and indirectly related to branching. Can you remember this concept, students? Yes. Now you only tell me. In both of this, whose surface area is more? This one surface area is more. If the surface area is more, boiling point will be more. SA more, boiling point is more, according to this. Perfect. Perfect. Now go back to the assertion and see. Yes, assertion, pentyl chloride has higher boiling point than pentyl. This is correct. Now reason: the branching of the chain makes the molecule more compact and therefore decreases the surface area. Just now we saw, yes, branching increases, surface area decreases. According to this, branching is inversely related to your boiling point. Same, if branching increases, surface area decreases. Correct na? So this is also right. Now you only tell me, yes, both are talking about the same concept. So assertion and reasoning both are true, and reason is a correct explanation of assertion. So which is the correct option, students? Option A is the correct explanation. Gradually I'm going, don't worry, go it gradually. So understand the concept. This is the concept. So this is one concept, this is second concept, this is third concept which I have written. Is it okay? Let us see the next question. Any doubts, ask me in the comment section. Next question. Tertiary haloalkanes are more reactive than primary haloalkanes towards elimination reactions. Okay, what is the reason? The plus side effect of the alkyl group weakens the CX bond. This is the concept. Let us go and understand the assertion. What did they say? Tertiary carbocation is more reactive than primary towards elimination. First of all, let us understand. This is the assertion part. Tertiary carbocation. Okay, what is the speciality of tertiary carbocation, students? You only tell me. Tertiary carbocation is more stable, correct? So done. Why it is more stable? Because of two factors. One is your hyperconjugation concept. One is your hyperconjugation. One more is the alkyl group branching. Alkyl group branching. These two are the more factors which makes the tertiary carbocation more stable. Now what happens is, in the rate determining step, when you're doing elimination, no? So in the rate, see, basically because of this, it mostly prefers E1 and E2 elimination reactions. Maximum reactions are preferred because of these two concepts. Now in this rate determining step, what does it form? It forms in the rate determining step, it forms tertiary carbocation. Tertiary carbocation, the most stable cation it forms. So because of this two concepts, it forms a more substituted alkene. More substitute, that is which rule, students? More substituted alkene in elimination reactions. Alkene in elimination reactions. Now you tell me which rule is this? Yes, you said it right. It is Zaitsev rule. Zaitsev rule is a combination. Now among all this, one more most important thing is your tertiary carbocation also prefers the less steric hindrance, because all the groups are molded together with less surface area. Correct? Na? So there is less steric hindrance also. All are molded together in one particular ring. So there's no much hindrance. So because of all these, tertiary carbocation is more preferred in elimination reactions. Can we go and see whether it is correct? Tertiary haloalkanes are more reactive than primary towards elimination. This is perfectly right. Let us go to the reasoning. The plus side effect of the alkyl group weakens the CX bond. Okay, just now we said tertiary plus side effect. So reason part, when I go, what did I say? So tertiary carbocation is because of hyperconjugation and alkyl group branching. Yes, that plus side effect also forms, plus side effect also has impact. But what is the main impact? The main impacted, but the main impact which is holding the cons or holding the particular thing is, main impact is because of what? Because of hyperconjugation and alkyl group branching. Alkyl group branching, correct na? Branching. Now what did they say? They said plus side effect is of alkyl, because of this only it is happening. This reason is correct, but this one is not supporting this, correct? Because because of hyperconjugation this is happening. So plus I effect. So I will go with the option B, where A is correct, R is correct, but R is not the correct explanation of A. I'll go with that concept so that it is clear that hyperconjugation is the main factor, not the plus I effect. That's right. Easy question, students. Next question. Let us go to the next question. Assertion type. Okay, they have given me here A tertiary, what is this compound? Can you name this compound? Yes, a tertiary group give your tertiary alkyl iodide and methanol or treatment with HI. Okay, they are saying this product is formed. Okay, please mention in the comment section the name of this. This product is formed when these two groups react when they treat with HI. Okay, now what did they say? This compound gives these two products. Okay, this compound when treated with HI, it forms two products is what they're saying. And the reaction occurs by SN1 mechanism. Let us reason separately. First of all, they said assertion. Let me take the assertion part and check. What did they say? They said CH3, C, CH3, your CH3. Okay, this is O and your CH3. What is it reacting with? It is reacting with HI. What does it form? The bond breaks. Yes, this bond cleaves and your iodine goes and attacks your tertiary carbocation. So I'll be getting tertiary iodide plus your methanol compound. Correct, na? Yes. So now you tell me whether we go back and see. In this particular case, this compound gives me these two products they said. So to some extent the assertion is right. Yes, to some extent no, it is perfectly right. I'll put a tick. Then they said the reaction occurs by SN1 mechanism. Now I have to reason it. So according to the reason what I write, remember students, the reaction whatever you have seen is an acid catalyzed reaction. Okay, this is point number one. Next, in this acid catalyzed reaction, what is acid? Here hydroiodic acid is acid. And what are they forming? It's forming let me erase this. It's forming tertiary alkyl iodide. Correct, na? Okay. And methanol. Okay, and methanol. Now, in this particular formation of tertiary this one, you tell me tertiary product is more preferred in SN1 or SN2? SN2. So this is an SN2 mechanism. Correct, na? It is not SN1. Am I right? Because what is it forming? It's forming tertiary carbocation, then iodine is getting attacked. So it is a tertiary carbocation means the order is 3 to 1. So it is SN2 mechanism. Go back and see the question. They said it is SN1 mechanism. So it is wrong. Shall I prove whether it is SN2 or not? I'll prove that. See this. This is the proof for SN2 mechanism. See here. First, this is your group. Correct? Then your HI is attacking. When this HI attacks, what happens? First, you get this product, protonated. Okay. Then to this, you will be the iodine, which acts as a nucleophile, comes and attacks. What does it do? This iodine goes and attacks the carbon, which is attached to a protonated oxygen. This is important in this stage. The incoming nucleophile attacks the carbon which is adjacent to a protonated oxygen. Adjacent to protonated oxygen. Correct? Then what happens? There's a cleavage of the bond and you get tertiary compound along with water. This is right. This is right. Okay. So now this whole thing is happening in single step. You only tell me this whole thing when it happens in the single step, which mechanism is this, students? This is nothing but SN2 mechanism. SN2 mechanism occurs in single step. Perfect? Perfect. So this is one proof. Next, what happens, further, whatever, how did I get methanol? I'll see. Further, whatever water is there, the hydroiodic acid catalyzed hydration, I said, na, it combines with water forming hydronium ion. This hydronium ion reacts with your iodine further, and it's going to form your HI, and water is released. This water and your hydronium ion, HI, hydroiodic acid, combines together to form your methanol plus iodine is out. This is all part of the reaction. So now what are you seeing? This whole step, whatever we are seeing, let me little bit erase. It has become a little bit thick, students. I'll make it thin. I'll make it thin for you so that you will not get confused. So the incoming nucleophile attacks the carbon which is attached to protonated oxygen. Okay. So with this all steps, what will I understand? That means your assertion is right, reason is wrong. Which option is this? Option is this. So option C. Assertion is true, but reason is false. Is it done, students? Done. Let us see the next question. So a little bit slowly I'll go. First one, then second one, then third. This is the fourth one. I've proved it. Got it, students? Let us see the next question. HI readily reacts with alkenes to form alkyl halides. Okay. Aqueous halogen acids are used to prepare alkyl halides from alkenes. Oh, very nice. Let us go to the assertion first. HI readily reacts with alkenes to form alkyl halides. Okay, let us take. In the assertion part, HI readily reacts with. Okay, first of all, students, reacts with alkenes to form alkyl. Okay, see here. If you want to convert alkenes to alkyl halides, always remember, okay, what will you use? You'll use hydrohalogen acids like HCl, HBr. What are these called? These are called hydrohalogen acids. Okay. Now what will this do? Simple. I'll show you some example. Now I'm going to take an alkene. Okay. Then to this alkene, I'm going to add HI. So what does it do? It's going to cleave the bond, and this iodine adds to the carbon with more alkyl substituted group. It goes and adds, this is one carbon, this is one carbon, this is carbon. Carbon goes and adds to the, iodine goes and adds to the carbon which has more alkyl substituted group. Okay, let's see the product. It is CH3, C, I, or H here, I here, and CH3. So what did I say? Iodine goes and adds to the carbon with more alkyl substituted group. Perfect. Now can we go back and see whether it is right assertion? HI readily reacts with alkene to form alkyl halides. Yes, it is right. Assertion is right for me. Now reason. Aqueous hydrohalogen acids are used to prepare alkyl halides from alkenes. That is also right. Just now I said, na? See here, aqueous hydrogen acids. Yes, reason part is correct, because whenever I have to convert alkene to alkyl halide, I require only one thing. Means I require what? Aqueous hydrohalogen acids. Yes, HCl is required, HBr is required. This is right, reason is right. But now you tell me, assertion is right, you said, reason is right. Now, in the reason, it did not explain about HI. Correct now. It is talking about HCl, it is talking about HBr. It did not explain, reason didn't explain about, did not explain about HI. Correct now? HI. So HI is not used in the aqueous solution as it is, because HI cannot be used. Why HI cannot be used? Let me write. Cannot be used in aqueous solution. Why I can't use an aqueous solution? Because HI is highly reactive with water. It is highly reactive with water. So because HI is highly reactive with water, students, I can't use it. So what happened here? Assertion is right. Reason also is right. But reason is not talking about HI. It is talking about HBr, HCl. That's why assertion is right, reason is right, but reason is not the correct explanation of assertion because this is talking about different options. So option B is right. Okay, then next question. Let us see the next question, students. Okay. Given below are two statements labeled as assertion reason. Okay. Halobenzene proceeds through SN2 mechanism with aqueous sodium hydroxide, not through SN1. Halobenzene proceeds through SN2 mechanism. Okay. The reason is the phenyl cation formed in SN1 mechanism is not stabilized by resonance. Let us answer this. SN2, what is it? Halobenzene proceeds through SN2 mechanism with aqueous. Okay, let us take the assertion. So, assertion, what is that? Halobenzene or bromobenzene? Okay, it proceeds to SN2, they say. So, this is my bromobenzene. Now, what am I doing? I'm taking sodium hydroxide aqueous. What will I get? The bond breaks here. OH goes and replace your bromine. I'll be getting phenol. Okay, whether this is SN2 or not, we will see. This is NABR. Okay, so normally aromatic compounds or haloarenes rather, haloarenes basically they mostly follow SNAR, substitution nucleophilic aromatic reactions, instead of SN1. Remember that. Why? I should have why also. No? Because of reason why. Why? Because lack of stable carbocation. When it converts into the product, there is lack of formation of stable carbocations. That's the reason it does not prefer the SN1. Instead of that, it prefers SNAR or SN2 rather. Okay, so that is a compound. So SN2 are common, and one more thing is SN2 are common in primary and methyl. Correct? SN2 are common in primary and methyl. Yes or no? Can you answer this question? SN2 are common. Okay. Let us take this to the reasoning part. What do they give me? The phenyl cation formed in SN1 is not stabilized by resonance acid. Okay, let's see. Reason part. Correct explanation of why halobenzene does not proceed via SN1 or the phenyl cation formed in SN1. It is not stabilized. Just now I said, no? It is not stabilized. So correct explanation, reason gave me correct explanation only. It is clearly telling the phenyl cation formed in SN1 is not stabilized by resonance. So it is also this, the reason part also is supporting the assertion. It has given me a correct explanation. What correct explanation reason has given me? Why? It is given a correct explanation of why halobenzene or the bromobenzene part does not proceed via SN1. What is the reason, students? Because phenyl cation formed, what a phenyl cation is formed is, or it is not stabilized. It is not stabilized. That is why stabilized by resonance. Not stabilized by resonance. Okay, so not stabilized by resonance. So unlike what? Unlike alkyl carbocations. Alkyl carbocations. So that's why what do I say? Reason also is right. Assertion also is right. Assertion is right. Reason is right. Both are explaining the same concept, no students. So can I put a tick here? Yes, tick here. So option A is the correct. Done. Let us go to the sixth question. Yes. Okay, sixth. Carbon atom attached to halogen in haloarene is more electronegative than in haloalkane. Okay, carbon attached to halogen in haloarene is more electronegative than in haloalkane. Okay, let us see this. So in assertion, I have taken the support for this diagram, so it's easy for you. They said in haloarene, the carbon is attached to which one? In haloarene, the carbon is attached to chlorine atom or the halogen atom. Okay. This halogen atom, what is it? What is it showing? It is showing resonance. See here, it is showing resonance. When it is showing resonance, what does it do? Because of this, it draws the electron density towards CX bond. See here, from here, the electron density, it's going towards the CX bond. It draws the electron density towards the CX bond. So because of this, what happens? The electron density increases here on carbon atom. That's why it is making that particular carbon more and more electronegative compared to carbon in haloalkane. Correct? I'm again explaining. First of all, see this question. Carbon atom attached to halogen in haloarene is more electronegative. This is right. Why? I'm going to show you now. Once again. First of all, in halo, let us put in words. In haloarene, okay, carbon atom, whatever carbon atom is there, that carbon atom is attached to which one, students? It is attached to halogen atom. Okay. Now, what is this halogen atom doing? This halogen atom exhibits resonance. This halogen atom is exhibiting resonance. Exhibits resonance. Okay, this is okay. When it is exhibiting resonance, what happens? It draws electron density. It's going to pull electron density. Electron density. Where is it drawing density towards? Which bond? Towards CX bond. Correct? No? It draws electron density towards CX bond. See here, see here, see here. So when it is drawing electron density, what will happen? The carbon which is attached, the carbon atom, whatever is here, na, this carbon atom, whatever is here, that carbon atom, there is more electronegative. Correct? Compared to carbon atom in HaloAlkanes. Correct? Na? Simple. So this is perfectly right. Next, reason. In haloarene, carbon is sp2 hybridized and having greater s character as compared to sp3 hybridized in haloalkane. Let us see. Go back. Let us take the reason. Now, this is your haloalkane. This is your haloarene. Correctness, students? Haloarene. Now, they said in haloarene, sp2 hybridized and having greater s character and compared to sp3 in haloalkane. Let's see. Here, what is the, in haloarene, what is S character? S character is equal to 33%. In haloalkane, S character is equal to 25%. Correct now? Yes. Yes. Now, is the reason right? Yes. Haloarene has more S character. S character. Is the reason right, students? Yes. Reason is perfectly right. Reason is perfectly right. Let us go back. Is assertion, reason both explaining the same concept? Yes. Both are talking about the same concept of haloarene. This is also haloarene. This is also haloarene. So reason also is right. So assertion right, reason right. Reason is the correct explanation for assertion. So option A is the correct one. Okay. Next question. Next question. Given below are two statements labeled as assertion reason. Okay, first, preparation of fluoroarene are not preferred by reaction of F2 in presence of Lewis acids. Okay, so preparation of fluoroarene is not prepared by reaction of F2 in the presence of Lewis acid, it seems. Reason, aromatic compounds not react in presence of Lewis acids. Let us do the assertion part. First of all, assertion. So preparation of fluoroarene. So I'm taking fluorine. So I'm taking benzene. I'm adding fluorine. I'm taking an Lewis acid. what does it do? It's forming fluorobenzene and HF along with certain byproducts. Certain byproducts. Okay. Now see. First of all, what is the role of Lewis acid? Role of Lewis acid. Lewis acid role is to to activate to activate fluorine molecule. To activate fluorine molecule to go and attack the benzene ring. That is the role of this. So now what happens here is, along with this, there is one additional product, HF is formed. What does it do? This HF is going to complicate the reaction. It complicates the reaction further. It's going to further complicate the reaction. So because of this, what happens? What happens? Go back. Preparation of fluoroarene not preferred by reaction of fluorine in the presence of Lewis acid. Yes, no. Because HF is formed as a byproduct, it is complicated. So the assertion is right or wrong? Yes, the assertion part is right because I have reasoned it in that way. Assertion is right. Now, aromatic compounds do not react in the presence of Lewis acids, they said. Oh, this is what Lewis acid is not required at all its influence. Let us see. Aromatic compounds do not react in presence of Lewis acids. So in electrophilic substitution reactions, aromatic substitution reactions, electrophilic aromatic substitution reactions, you only tell me, do they require Lewis acids? Yes, aromatic do not react in presence of Lewis acids. Compounds not react in presence of Lewis acids, they said. So normally, when the electrophile attacks, no, it activates and immediately it goes and forms the product. In any nucleophilic aromatic substitution reactions, let us reason that. So when you have any nucleophilic aromatic substitution reactions or electrophilic aromatic substitution reactions or EAS, so automatically what happens? The electrophile nucleophile goes and attacks the ortho and the para position because of the benzene ring. Correct na? Yes. So here what is happening is, before we go to the next question, you should understand this option also is correct. But this is talking about fluorine, fluoroarene. This is talking about Lewis acid. That means assertion and reasoning are true, but R is not the correct explanation of A. That means option B. This is the answer. Both are talking about a different concept. That's why that is not the correct explanation of B. That's easy. Okay. Next question. Chlorine is orthopara directing group in electrophilic substitution reactions. Chlorine is an electron withdrawing group due to inductive effect. So chlorine is orthopara directing group. Yes or no? Let us see. See this. Now this is the assertion part. Let us take it. So here what happens? What chlorine is a deactivating group, correct na? First of all, chlorine is a deactivating group. I'll keep that in mind and then start explaining. Okay. So what happens whenever an incoming electrophile or whenever an electrophile attacks? So what does it do? It directs this incoming electrophile to ortho position and para position. Correct? It is deactivating. So due to resonance stabilization of the arenium ion, whatever arenium ion forms, no, because of this resonance stabilization, see here it is written, resonance affects the stabilization of intermediate carbonate. So because of your deactivating group and because of the resonance stabilization of the arenium ion, resonance stabilization of arenium ion. So what happens? What happens? Chlorine makes the incoming electrophile to come to the ortho position and para position. Is it right or wrong? Let's go back and see. Chlorine is an ortho para directing group in electrophilic substitution. This is right. Next. Chlorine is electron withdrawing group due to inductive effect. Let us reason that. This is my reason. Let us see. Chlorine is more electronegative than carbon. Point number one. Yes. Cl is more electronegative than carbon. Do you accept this? Yes, accept. Okay. Next, what does it do? It withdraws the electron density from benzene ring. See here, you're able to see benzene ring. It's drawing the electron density. It's drawing the electron density towards it. It draws the electron density. When it draws the electron density towards it via benzene ring, the inductive effect, whatever is there, which will help to stabilize the positive charge, no? That develops at the ortho and the para position. See here, it develops at ortho position and it develops at the para position. Whatever is there, see this para position and at the ortho position. So chlorine being more electronegative, what does it do? It withdraws electron density from benzene ring. So when it withdraws electron density from benzene ring via which effect? Via inductive effect. Okay. So what will happen because of this? This helps to stabilize the positive charge, whatever positive charge is there, no? It helps to stabilize the positive charge. Because it helps to stabilize the positive charge during electrophilic addition reactions. That's why ortho and para products are formed. This is the reason, as you have seen. It is more stable. So go back to the reason. Chlorine is electron withdrawing group due to inductive. Correct, na students? Yes, no? Yes. See here. This reason and this reason. Because of this inductive effect only, or the para-directing group it has become. That means assertion and reasoning are right. And reason is a correct explanation for assertion. This is right? Perfectly right. Let us go to the next question. Okay. This is blank. This is blank page. This is blank. Okay. Next question. Assertion. NO2 group activates HaloArenes from electrophilic substitution. Reason. NO2 group is an electron withdrawing in nature. Fine. Let us understand. NO2 group activates HaloArenes for electrophilic substitution reaction. Okay. What is the assertion? We'll see. What is assertion? NO2 group. First of all, what is the specialty, students? NO2 group is an electron withdrawing group. Do we understand that? Yes. Now, due to why it is electron withdrawing group? Because of this oxygen atom here. Because of this oxygen atom, what happens? Nitrogen gets positive charge and oxygen gets negative charge. Correct? That is right. Due to oxygen atom, because that is more electronegative, due to oxygen atom, nitrogen gets positive charge and oxygen gets negative charge. Now what will happen? There is charge separation, correct? So because of this, resonance delocalization happens. This see here. Charge D one after the other, it is shifting. Because of this, resonance delocalization of electron density happens. Because of this, there is an overall stabilization of the molecule. Because this is charge difference, na? It shifts, the pi bond shifts and the electrons shift. There is resonance delocalization of electron density. Resonance delocalization of electron density. So because of this, what happens? There is overall stabilization of molecule. Overall stabilization of molecule. Is it right, students? Molecule. Now let us go back to the question and see. NO2 group activates HaloArenes for electrophilic substitution. Yes, correct. Next, NO2 group is an electron withdrawing group. Okay. Reason. Correctness, students. Just we discussed NO2 is an electron withdrawing group. So reason is right. But you tell me, assertion is talking about NO2 group activates ESR. NO2 group is electron withdrawing in nature. Here what happens, this is talking about activation. A is talking about activation, assertion, and B is talking about electron withdrawal. That's why B no reason. Both are different concepts. Both are different concepts. That's why, go back. The option here is assertion is correct, reason also is right. But assertion, reasoning are two. Reason is not the correct explanation of assertion. So I'm going with option B. Got it? Next question. Next question, students. Let's read the next question. Okay. 10th question. The reagents of electrophilic substitution reactions of haloarenes have presence of acids or Lewis acids. Okay. So electrophilic substitution reactions. Okay, this is the assertion part which I'm going to pick up. So what are the different electrophilic substitution reactions? Nitration is one. Okay. Okay. Here the electrophile is NO2 plus. Halogenation is one. Halogenation. This is Cl plus. Sulfonation is one. This is SO3H. Then Friedel-Crafts alkylation. Friedel-Crafts alkylation. Friedel-Crafts. What is the group? CH3 plus. Friedel-Crafts acylation. What is the group here? CH3CO plus. Correct. Now for all these, what is required? What is required? The one acylation. What is required? Lewis acid is required. See here, Lewis acid is required, which will activate. It's forming chloronium ion. Lewis acid is there, it's activating. Lewis acid is there, activating. This is alkylation. This is your this one, chlorination, alkylation, acylation. Now, for all these cases, what is required? Lewis acid. Go back to the question. The reagents for electrophilic substitution reactions of haloarenes have or require presence of Lewis acids. 100% yes. It will activate the electrophile. Next. The acids or Lewis acid helps in generation of electrophile. You're able to see now? You're able to see, right? Reason everywhere? Yes. Lewis acids, whatever are there. Lewis acids, whatever Lewis acids form, they form or whatever in the presence of Lewis acids. Lewis acids form highly reactive electrophiles. They form highly reactive electrophiles. That means assertion is right. Reason is right. Reason is talking about assertion. Go back to the option. Which option is this? Option A. Both are talking about the same concept. So option A. Easy? Easy. Right, next question, students. Let us go to the next question. Yes. Phosphorus halides are chlorides rather. Phosphorus chlorides are preferred over thionyl chloride for the preparation of alkyl chlorides from alcohols. PCl phosphorus chlorides give pure alkyl halides. So phosphorus chlorides are preferred over thionyl chloride. Let us see. Phosphorus chlorides. Okay. Let us write the reaction. ROH plus SOCl2 gives me RCl. Here, this is a gas which vaporizes. HCl, this is a gas which vaporizes. And this is pure alkyl halide. Okay. So, they said phosphorus trichlorides are preferred over thionyl. Let us write the phosphorus trichloride reaction also. ROH PCl3. I'll be getting 3 RCl because you're taking 3 alcohols plus H3PO3. Okay, here there is a byproduct formed. This is not pure, correct? Then let us go to PCl5. Let me take one ethanol. I'm taking PCl5. Okay, now what happens? This is C2H5Cl plus HCl plus POCl3. Here, this is also not pure. Correct, na? Right. Now you tell me, go back to the question and see. Phosphorus trichloride is preferred over thionine. This is wrong, na? Right? See, assertion and reasoning. If I have to say assertion and reason, SOCl2 is preferred. Here they said phosphorus is preferred. So this is wrong. Phosphorus chlorides give pure alkyl hydride. This is also wrong. So what is the correct option, students? Assertion and reasoning, both statements are wrong. So here option 2, both are wrong, because in this case it is SOCl2. In this case SOCl2. So both statements are wrong. Correct, na? So remember, in the reason always, whenever you want pure yield of alkyl halides, what should you take, students? You have to take SOCl2, because it forms gaseous products. What does it form? It forms gaseous products. Is it okay? Done. Let's see the next question. The boiling point of alkyl halide decreases in the order of Ri, RBr, RCl, RF. Okay. The boiling point of alkyl halide or alkyl chloride, bromide and iodides are considerably higher than that of hydrocarbon of comparable masses. Okay. Done. Now check, students. Careful. The boiling point of alkyl halide. First of all, what are you saying? Whenever somebody says RiRCl, boiling point increases as size of halogen atom increases with same alkyl group. Am I right? So is the first option correct? Yes, this is right. As the molecular mass increases, no? Because boiling point increases as the halogen atom means more molecular mass. This is okay. Next question. The boiling point of alkyl chlorides, bromides and iodides are considerably higher than that of hydrocarbon of comparable molecular mass. This is also right, because as the size of the halogen increases, same alkyl group, the molecular weight keeps increasing, so boiling point is also right. But this is talking about same alkyl group and different halogen atoms. This is talking about alkyl chlorides and hydrocarbons. Both the concepts are different. That's why assertion and reasoning are correct statements, but reason is not the correct explanation of assertion. That's that. Easy? Easy. So next one, next question. KCN with methyl chloride reacts with methyl chloride to give methyl isocyanide. Okay, let us see whether it is correct or not. Assertion. KCN with methyl chloride. So please understand, students, it forms a compound called methyl cyanide plus KCl. This everybody knows. Now, under harsh conditions, when you are applying very harsh conditions to the particular reaction, you know what happens? This methyl chloride plus KCN, it further forms methyl isocyanide plus KCl. Now, why are we studying this only in the textbook? Because here there is carbon-carbon bond stability. Carbon-carbon bond stability is there. That's why this product is more preferred compared to this. But here what happens, this is carbon-nitrogen bond. But here carbon-carbon, more bond stability is there. That's why KCN forms methyl. So what did they give me? They say KCN reacts with methyl chloride to give methyl isocyanide. Wrong, na? It gives methyl CN, not methyl NC. So the statement is wrong. What is reason? CN is an ambidentate nucleophile. Yes, it can attack from both the sides. It can attack from carbon. It can also attack from nitrogen. So assertion is right. Assertion is right. Whereas assertion is correct. Okay, assertion is wrong. Reason is correct. So option 4 is the correct answer. Okay, now let us go to the next question. Tertiary butyl bromide undergoes Wood's reaction to give 2233 tetramethyl butane. Okay, in Wood's reaction, alkyl halide reacts with sodium in dry ether to give hydrocarbon containing double the number of carbon atoms present in the halide. Okay, this I know because Wood's reaction is always increasing the chain, right? So I'll put a tick here. This is already right. Okay. Tertiary butyl bromide undergoes Wood's reaction. Let us see this. Assertion. Assertion. Tertiary butyl bromide. This is my compound. This is bromine. This is tertiary butyl bromide. Correctness, students? Okay. In the presence of dry ether. This is important. Dry ether. Okay. Now you see what happens. 2NaBr is out. So what do I get? I get CH3, CH3, C, CH3, CH3, CH3 plus 2NaBr. Now label this compound. Okay, this is 1, 2. Okay, it is 2, 2. Then 3, 3. Then how many methyl? Tetramethyl butane. Correct, na? So is the assertion correct? Yes. In tertiary butyl undergoes Wood's reaction to give? Yes, this is perfectly right. Both are right. Correctness, students. So assertion is talking about Wood's reaction. Reason also is talking about Wood's reaction. So assertion is right. Where is it? Assertion, reason, both are right. Reason is the correct explanation for assertion. So option perfect. Yes. Next question. This is a blank page. Already explained. It's blank. Okay. Next question, students. In mono-HaloArenes, further electrophilic substitution occurs at ortho and para positions. Okay. Mono-HaloArenes. Electrophilic substitution occurs at ortho and para. Okay. Let us answer this assertion question. In halogenation or mono-HaloArenes. So, first of all, halogens are ortho and para directing groups. Ortho and para directing groups. Why? Because of plus M effect and plus R effect. Plus M effect and plus R effect. Okay. So go back and see whether they're right. Mono-HaloArenes, further electrophilic substitution occurs at ortho and para. This is perfectly right. Halogen atoms are ring deactivators. Yes. Why? Because of high electronegativity. Correct? Now see the option. Assertion is right. Reason is right. But here it is talking about deactivators. It is talking about ortho and para. Assertion is right. Reason is right. But reason is about a different concept. Assertion is about a different concept. That's why I'm going with option 5. Both are correct, but reason is not the correct explanation. So option 5. Done. Next question. Aryl iodides can be prepared by reaction of arenes with iodine in the presence of an oxidizing agent. Aryl iodides. Oxidizing agent oxidizes iodine to HI. Let us take this assertion part. What is this? Aryl iodides can be prepared, okay, by reaction of arenes with iodine. Okay, I am taking phenol. I am adding iodine in the presence of an oxidizing agent HNO3. what happens? This iodine goes and attacks at ortho position and it attacks at para position. Okay, this is okay. Done. So they told us aryl iodides can be prepared by reaction of arenes with iodine in the presence of oxidizing agent. That's right, na? That's right. Next, they said oxidizing agent oxidizes iodine to Hi. They said oxidizing agent oxidizes iodine to Hi. Okay, I'm taking oxidizing agent. I'm taking Hi. What will it get converted? This is an oxidizing agent, OA. It will get converted to water and iodine molecule. Let me balance it. This is 5, this is 3, this is 3. Okay. So, what did they say in this question? They said oxidizing agent oxidizes It to Hi. But what is happening? What is happening here? Given, what did they give? They said oxidizing agent converts I2 to Hi. But actual actual equation is Hi is getting converted to I2, oxidizing agent. This is the actual reason. That's why the given reason is wrong. Correct, na? So what did they do? The reason, whatever reason is given, it is wrong. So what is the correct option you're going with? Assertion is right, correct, but reason is wrong. So option 3. I'm going with option 3. Option 3. Okay. Chalo. Next question, students. Very important questions we are doing. It is difficult to replace chlorine by OH in chlorobenzene compared to that of chloroethane. Okay. Chlorine carbon bond in chlorobenzene has a partial double bond character due to resonance. Let us see this. It is difficult to replace chlorine by OH in chlorobenzene. So this, see the assertion part. It is very difficult to replace chlorine in chlorobenzene. Why it is difficult to replace by OH, students? Okay, what is happening? Chlorobenzene compared to chloroethane, what happens? In CCl, there is partial double bond character. Correct? Partial double bond character. There's partial double bond character. Right? Done. Because of this partial double bond character, it shows resonance. Done. Now you only tell me. Is it easy? Is it easy to replace? Is it difficult? Yes. Hence difficult to replace OH group by Cl. Go back. It's difficult to replace OH in chlorobenzene. This is perfectly right. Next, CCl bond in chlorobenzene has a partial double bond character. You only see it is there, na? Double bond character. What will I write? Yes. The reason is CCl bond has partial double bond character. It has partial double bond character. Okay. Because of partial double bond character and it shows resonance. Accepted? Accepted. So go back to the question now. CCl shows partial double bond. This is also correct. So both are talking about the resonance part because of the resonance, OH is not replaced. Both. That means assertion is right, reason is right. Reason is supporting the assertion statement. Which option is that, students? And assertion and reasoning are right and correct reason. So option 1 is a correct answer for this. Okay, right. Next question. Hydrolysis of 2-bromo-octane, okay, proceeds with inversion and configuration. Whether it is right or wrong, let us see. Inversion. So first of all, I'm going to take 2-bromo-octane, which is octane. This is octane. Na? Let me write CH3H hydrogen. This is 2 bromo. 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8. 3, 6. Okay, I'm CH2, 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 CH2. I'm just filling it. Okay, CH2 and CH3. Now can I just condense it and write? I'm writing as C16, C6H13, and this is bromine. This is your CH3. This is your hydrogen. Okay. Now what is it affecting? It is proceeding to inversion, hydrolysis. So hydrolysis. What will happen? There is a formation of transition state here. The formation of transition state. Above is C6H13 and CH3 and H. This is your transition state formation, correct? Yes. Now after transition state, what do we observe? We observe C6H13, CH3 and H. What did you observe? Here there is backside attack of Watchmans, and there is inversion of configuration. So now you only tell me backside attack, inversion of configuration. It happens in which one? In SN2, correct? So do you accept that there is inversion configuration? Seeing the product? Yes. Go back. Hydrolysis of bromo-octane? Yes, it is inversion of configuration. Now, the reaction proceeds to the formation of carbocation. In SN2 mechanism, in SN2, there is no carbocation formation, but only transition state is formed. Transition state is formed. Is it okay, students? Is it okay? Yes. Done. So go back to the question. Reaction proceeds to formation. Reason is wrong. So what will I write? Assertion is right, reason is wrong. Which option can I go? This one. So option 3 is the correct one. Okay. Chalo, next question. Nitration of chlorobenzene leads to the formation of meta-nitrochlorobenzene. Nitration of chlorobenzene itself. Okay, shall we see what is nitration of chlorobenzene first of all? I'm writing the heading. Nitration of chlorobenzene. What is nitration of chlorobenzene? I'm taking chlorobenzene. I'm adding nitrating mixture HNO3 and H2SO4. The electrophile is NO2 plus. So what will I get? I'll be getting two products. One is ortho product. One is para product. Okay, this is one concept. Okay, done. I'm getting ortho product and para product. What is this? This is 2-chloronitrobenzene. This is 4-chloronitrobenzene. 2-chloro and 4-chloro. Now I am doing this. I'm underlying, students. Please don't mind. I'm writing with the writing pad. That's why my handwriting is vague little bit. That concept is important, students. Chlorination of nitrobenzene. Let us do. Chlorination of nitrobenzene. What do I get here? I'm taking nitrogen, NO2. I'm doing chlorination, FeCl3. So what will I get? I will get NO2 and I'll be getting your Cl. Correct? Chlorination. Okay. Why I'm getting meta? Because nitro is meta directing group. Okay. Go back to the question. Nitration of chlorobenzene leads to the formation of meta nitrochlorobenzene. See here, nitration of chlorobenzene, what is it giving? No. Nitration of chlorobenzene gives me 2 chloronitrobenzene, and it gives me 4-chloronitrobenzene. 4-chloronitrobenzene. Is it right? The statement is wrong. Okay. Reason. Nitrobenzene is meta-directing. Yeah. Nitro group is meta-directing group. That's perfectly directing group. So the reason is perfectly right. Go back. Reason is right. Okay. So assertion is completely wrong. Reason is completely right. And reason is talking about. Can I just directly go to this? Yes. Assertion is wrong. Reason is right. Correct, na? Reason is right. So can I go with option 4? Because there's no other comparison also. Option 4. All right. Any question? That's all? Oh, that's all, students. Oh, that's great. So we have completed almost 19 assertion reasoning questions. Assertion and reasoning questions. Very, very important. Correct, na? Very, 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 very important questions. Compulsory, you'll be getting question. So this 19 most, I request all of you to please like the video, please share the video. It took almost 1 hour to teach with this throat. So please like the video, share the video. You can always buy thanks, super thanks. They say buy super thanks. No, that option also is there to show your gratitude, students. Okay, thank you so much. Bye bye, take care. Thank you. See you next video in board papers. I'm going to teach board papers, and I'm going to send 5 marks questions and 5 marks questions. 5 marks questions. Take care. Bye bye. Thank you and good night. Thank you.